In this video, we're going to talk about 2.4 Objective 5, where we find vertical asymptotes. We're going to do this with the limit process by using one-sided limits. So let's answer the question about what happens with the limit of f of x as x approaches 2. We don't know because we get 0 over 0 right now. So we're going to have to do some algebra and factor this. So we're going to say that the limit as x approaches 2 is 1 over x plus 2. That will cancel. That's going to be 1 over 4. X plus 2 is 1 over 4. And then as I get close to 2 from the left, I'm still going to sorry, as I get close to -2 from the left, -2 is what was giving me the 0 down here still. So as I get close from the left, I'm going to have a negative in the denominator. Positive divided by a negative is a negative. So I'm going to get close to negative infinity. And as I get close to -2 from the right, I'm going to have a positive number in the denominator, and 1 over a small positive number is going to tend towards positive infinity. And so there's a vertical asymptote that occurs at x equals -2, because that's the factor that's left remaining in the denominator here, that if I set it equal to 0 and solve, I get x equals -2. All right. This is the same as x minus 14 over x plus 14 times x minus 14 is x is 1 over x plus 14 as long as x is not equal to positive 14. There's a hole there in the graph at x equals 14. So as I get close to 14, I get 1 over 28. I want to just answer that as 1 over 28. As I get close to -14 from the left, I'm going to get close to negative infinity. As I get close to -14 from the right, I'm going to get close to positive infinity. And there's a vertical asymptote at x equals -14. Right? Now let's factor this guy here. This is x minus 3, x minus 6 over x minus 3, x minus 2. That's going to be x minus 6 over x minus 2, as long as x is not equal to 3. So there's a hole in the graph at x equals 3. And that's going to be 3, -3 over 1 is -3. So there is a vertical asymptote at x equals 2. Limits of this vertical asymptote are, as I come from the right, it goes to, let's look here. So I come at 2 from the right, this is negative, and this is positive, so that's going to be a negative infinity. As I come at 2 from the left, this is negative and this is negative, so that's going to be positive infinity. And the limit as I get close to A does not exist. So we're on this piece because it's different limits from the left and the right. So I had to start filling in blanks and see which one I was on. I'm on B there. All right. And they didn't ask us about the hole in the graph, but the hole in the graph is at 3, -3. Let's see here. This is x times x squared minus 10x plus 25. So minus 2. X minus 2 over x times x minus 5 quantity squared. No holes. There's two vertical asymptotes. One of them is at x equals 0 and the other is at x equals 5. So we are option D here. The leftmost vertical asymptote is at x equals 0. And the rightmost asymptote is at x equals 5. As I get close to 0 from the right, so a slightly positive number, this is negative, this is positive, and this is positive. So that's going to get to negative infinity. And as I get close from the right, this is going to be a, I'm sorry, from the left, this is going to be a negative, and a positive is going to be a positive infinity. Limit does not exist because it's neither positive nor negative infinity. And as I approach 5 from the right, so a number slightly bigger than 5, that's positive, positive, and positive, goes to positive infinity. 5 from the left, so a number slightly smaller than 5, that's positive, positive, and this will still be positive because a negative squared is a positive. That's positive infinity, so that limit goes to positive infinity since it's the same from the left and the right. Let's go ahead now and look at number 5. Find all vertical asymptotes in the form of x equals a of the following function, and then find the limits from the left and the right, and the limit if it exists. Use infinity and negative infinity where appropriate. X times x squared minus 12x plus 32 over x times x minus 8. So that's going to be, let's factor that, x minus 4 and x minus 8. The x minus 4, as long as x is not equal to 0 or 8. There's holes in the graph there. There are no more vertical asymptotes though, because there are no more remaining zeros in the denominator. So no vertical asymptotes. Ooh, we get x to the 9th times x minus 7 in the bottom. And we get x minus 3 times x minus 7 on the top. This is x minus 3 over x to the 9th. X cannot be equal to 7. There will be a hole in the graph there, but we're only interested in the vertical asymptote, so that's going to happen at x equals 0. It's A. And we shouldn't have gotten this question. I meant to delete this question and this question. Oh, no, we can get these questions. Sorry, I forgot. We're okay. Use analytical methods and or graphing utility to identify vertical asymptotes, if any. All right, so we're going to look at the fact here that x equals -6 has to be a vertical asymptote here. Let's go ahead and just write that in. And sine is not going to give me any asymptotes. It's never undefined. Now, 8, that's much more interesting. I have to think of all of the places where tangent is normally undefined. So pi theta over 22. Tangent is normally undefined at odd multiples of pi over 2. Plus or minus 2k plus 1 pi over 2. So the theta is going to be equal to plus or minus 2k plus 1 pi over 2 times 22 over pi. And this is theta equals plus or minus 22k plus 11. So 11 plus or minus 22k. So that's B. They're not going to say plus or minus because they're going to say that k can be any integer, including negative. So there we go. This is the same thing as cosine of x over square root of x. Cosine doesn't have any asymptotes involved with it. I'm only concerned with where the square root of x equals 0. So x equals 0 is my asymptote. Use analytical methods and or graphing utility to identify the vertical asymptotes, if any, of the function. So we have the square root of x times the square root of x squared minus 2. So x equals 0. This is this going to be the square root of x. Let's just set it like this: x squared minus 2 equals 0. X squared equals 2. X equals plus or minus root 2. However, x shouldn't be able to be negative root 2. Let's check that to be sure. Because I need to have a positive inside of that square root. So I think I have zeros of the denominator at negative root 2, 0, and positive root 2. Those might be where my asymptotes occur. And then I need to be sure here that, okay, so when I have a negative number, then this is going to be a positive number. That's going to be a negative, and there's nothing over here. When I have something that's between here and here, like a -1, then that's going to be a negative times a negative is a positive, and that's okay. And then between, say, 0 and that, so like 1, that's does not exist there. And then over here is going to be 2. That's going to be okay. So my asymptotes are at these 3 places here, but they're only one-sided, and they are, let's see, x equals negative root 2, x equals 0, and x equals positive square root of 2. All right, this is going to be x times x minus 4. This is going to be x minus 5 times x minus 4. It's x minus 5 over x as long as x is not equal to 4. And as we get close to 0 from the left, that's a negative over a negative is a positive infinity. We get close to 0 from the right, that's a negative over a positive is a negative infinity. As we get close to 4 from the left, that's a negative over a positive there. We're getting close to negative 1/4. As we get close to 4 from the right, that's a negative 1/4 still. Because I'm getting close to a point on the graph, I'm squeezing in on that point. It's a hole, but it's like there was a point on this graph that I removed, and the point would have been 4 negative 1/4. So there's a hole at 4 negative 1/4. Does your graph have any vertical asymptotes? Yes, at x equals 0. Which is the correct graph if we would use a graphing utility. So we have, let's just identify here that we have a horizontal asymptote y equals 1, a vertical asymptote of x equals 0, x-intercept of 5, 0, y-intercept of, there's none because there's a vertical asymptote there. So horizontal asymptote of y equals 1 is going to give me B or D. And there's no y-intercept, so can't be B, it's got to be D. All right. Next, graph F, noting errors obtained from the graphing utility. So the graphing utility can't show you the hole in the graph. It's just a pixel wide. So you're going to have to graph the hole in the graph that is at 4 negative 1/4. So it's going to look like one of these, but it's got to have 4 negative 1/4, so that's got to be A. And that's it for this video, and we'll come back next time and we will talk about 2.4 objective 6. So see you for the next video.